So this is going to be the third molar conversion, and this is looking at moles to volume. And for moles to volume, this one is a little bit different than the other two. So the first two that we've talked about is converting moles to mass, or mass to the number of moles. The second one is the number of things with Avogadro's number. This one is about volume of a gas. So this one only applies to if you have a gas. So what this is saying is that there is a Avogadro's hypothesis that's stating that if you have 1 mole of gas, because remember, the nature of gas can be, that nature of gas that the molecules can fill out the space of the container, right? So what Avogadro's hypothesis is that if you have 1 mole of gas, you are always going to have 22.4 liters. Or in other words, if you have 22.4 liters of any gas, you're going to have 1 mole of it. So if you look at this, Avogadro's hypothesis is basically saying that there is an equal volumes of all gases at the same temperature and pressure. This is going to be at STP. Okay, so what exactly is STP? STP stands for standard temperature and pressure, and this is when the environment is at 0 degrees Celsius and with 1 atmosphere of pressure. So if you have 4 containers that is at 22.4 liters, that is at STP. So meaning that they're all at 0 degrees Celsius and that they all have the same amount of pressure, which is 1 atm. The number of particles you have is going to be the same for each of them, of all the gases. Okay, so 1 mole of this helium gas is going to be the same number of particles in here compared to 1 mole of nitrogen gas, compared to 1 mole of ammonia gas, 1 mole of methane gas. So all of those will have 22.4 liters for all of them. So that's the key number, is that 22.4 is going to be the same for all gases. So how does that relate to our molar conversions? Well, now that you have another conversion to look at how we convert to the amount of gases, let's take a look at an example here. So how many liters would 0.005 moles of ammonia gas have? So remember, this is gas, so because it's a gas, you can use the 22.4 liters. This does not apply to solids or liquids, because if you remember, solids and liquids are very densely packed, and the amount of how they're packed will affect their masses, right? But because gases, the molecules can, fly around in the container. It can either be very dense, it could be very sparse in the container. We know that through Avogadro's hypothesis that 1 mole of a gas is always going to be 22.4. That's the fact. That's the certainty. So given this example, we're going to start off with 0.005 moles here, and we're going to do our conversion. So we're going to have the times division bar, and we're trying to get rid of the moles, so we're going to put moles at the bottom, and then we're going to have liters at the top because liters is what we want. And our new conversion factor now is with 22.4 liters for 1 mole, so we can cancel out the moles and get you this number. So let's see if I can pull up my calculator. So 0.005 times 22.4, and that's going to give me 0.112. So 0.112 liters. So if you have this amount of moles, you're going to have this amount of gas. So let's look at another example. This one is going to the other way, which is that you're looking for the number of moles, and you're given the volume of this carbon dioxide gas. So you notice that it doesn't even matter what element I have, or compound here. I can have ammonia, I can have CO2. It doesn't really matter how I convert this to moles, because remember, the liters is going to be the same. So let's start off by writing 140 liters. This is going to be times division bar. I need to get rid of this liters unit, so liters is going to be at the bottom, and moles is going to be at my top. My conversion factor is that for every 1 mole, I'm going to have 22.4 liters. So this is your new unit conversion factor, right? And you notice that your liters are going to cancel out, and what you're going to do is 140 times 1 divided by 24. So let me punch that in. So 140 divided by 22.4, and you're going to get 6.25. So 6.25 moles of CO2. So this, if you have 140 liters, that's quite a bit of liters. You're going to have 6.25 moles. So that's your third conversion factor. The next part of this is where you have two-step questions, right? So the next video I'm going to talk about is, well, instead of looking at moles, can you calculate how many molecules of CO2 you can have with 140 liters of the gas? So that means that you would have to take an extra step. So check out the next video about two-step questions. But this one, to summarize, this one is about your molar conversion of your gases only, and your new conversion factor is 22.4 liters for every 1 mole. So thanks for watching.